Okay. Hi, my name is Ian Lacey. Um, Today we are going to do a presentation about E. coli. Um, and I am also joined by Natalie King and Summer Weber. So first we're going to talk about the microorganism. It was discovered in 1885 by Theodore Escherich. The virus is also named after him since he discovered it. It's considered philosophative, which means that it doesn't need oxygen to grow. It can grow without it or with it. It is gram-negative. It's rod-shaped. Uh, it's non-sporing, flagella, and is motile. The growth degree is 37 degrees Celsius, or that is 98.6 degrees Fahrenheit. There are different types of E. coli. There's harmless, one found in the normal flora of the gut. Um, it actually produces vitamin K. Harmful types infect the intestines and fecal matter, causing diseases to the warm-blooded mammal. Here is a picture to your left of what is inside an E. coli. You can see the cell membrane, the flagella, the DNA. And then to the upper right is the good uh, bacteria, which is E. coli K12, that is in our gut, and E. coli 0157, which is the bad one, which is usually found in contaminated foods such as meat.
Okay, so potential problems that come up with E. coli, if it were to be eradicated, there would essentially be no beneficial strains of E. coli that live in our gut. So slower breakdown of digestion would happen, um, essentially no food breakdown, no absorption, and vitamin K2 would not be produced. What the world would be like without it, the pros for it: there's no more harmful strains found in our food. People would not be experiencing diarrhea, vomiting, stomach cramps after being infected, and the drinking water would be cleaner. The con is that good bacteria from our gut would be gone.
Could we solve the problem? Chemical X can get rid of E. coli, but it can also kill the good E. coli. Here's how you could solve the problem. One way is if the good E. coli becomes anti-resistant to chemical X. And then another example would be getting rid of K12, which means we would have to substitute what the bacterium can no longer give, like B7, B12, vitamin K, and laxatives. The potential cost, another way of saying that is, what is the potential cost, meaning if the good E. coli was eliminated, what would we do to replace it, and is it worth it? I don't feel like it's worth trying to replace E. coli because it could deactivate the good E. coli if we try to get rid of the bad ones. And there's too many benefits that would be difficult to make using other forms besides E. coli, like the reproduction, digestive, and immune health. The body would be at risk for different diseases like Parkinson's and Alzheimer's. So I don't think we can come up with anything at the moment that would replace the good E. coli.
Eradication. To jump on what was just said, an overview of bacteria. So we've learned what the two types of E. coli are. The most two common types, which is K12, which is in the gut, and 0157, which is the most common to make people sick. And we've learned about the good, the bad, and the ugly. Um, Now about this chemical X, we're talking about refining this chemical in the first place before we even think about eradication. I think there needs to be some refining done to make the good K12 uh, bacterium anti-resistant to the chemical before anything else. So I would recommend uh, not to do the eradication just yet. I think we need to go back to the drawing board and solve the problem of not getting rid of uh, K12 because without it, there's a lot of complications, or we have, like was said before, we got to find other ways to get what would be missing in our body. So this wraps up um, our presentation, and I hope you enjoyed learning about E. coli and the benefits and the good, the bad, and the ugly.